So I want to use this as an example to show you here some uh, some issues you may encounter when you solve questions related to the annuity. In our course, we only talk about the calculation of what we called the ordinary annuity, which means the first payment starts by the end of the year, right? Because we said we always assume that we stand at the beginning of the year. So ordinary annuity means that the payment occurs by the end of the year. So that means the first payment starts from year one. So that's the how we can use the formula. Uh, but sometimes the first payment may not start from year one. So like in this example, it actually starts from year six. So this is question number 12 in your homework number 2. So let me first read the setup. What is the value today of $4,300 per year at the discount rate of 10%? And we said that if we are calculating the present value, the interest rate can also be called the discount rate. So by reading this, you should understand the interest rate is 10%. So, and if the first payment is received 6 years from today, as we just said, sometimes the first payment may not start from the end of the year or relative to your current year, which is year 0. But here it actually starts from year 6. And the last payment is received 20 years from today. So why don't we draw a chart so we can better understand what this means. So what happens is we have every year 1, 0, 1, 2, 3, 4, 5, and then 6. So the setup says starting from year 6, right? If the first payment is received 6 years from today. So starting from year 6, you will receive a constant payment because it's annuity. So the payment amount is 4,300. So let's continue this chart. Basically, yeah, you don't have to do all this. Basically, it just goes to I believe 20 years from today. So this is 7, 8, 9, 10, and this is 19, and finally 20. So every year you're going to receive 4,300. So that's basically what happens. And it's asking, what is asking for? It's asking for what is the value today, right? It's asking for what's the value today. So that means we need to calculate the present value in terms of the true present value of this annuity. But again, this annuity is kind of unusual because if we in general the annuity start the first payment should start from here, right? But that's not the case. So the first payment here starts from year 6. But then how can we analyze this question with the annuity formula? Because this formula, present value formula, present value of annuity equals payment, right? Annual payment, constant payment times 1 minus 1 plus interest rate raised to the power of negative t, because we are calculating present value, so the power needs to be negative, and divided by the interest rate. So that's the formula for the present value of an annuity, of an ordinary annuity. But again, this formula only applies when the first payment starts from year 1. But unfortunately, in this case, the first payment starts from year 6. So how can we apply this formula? If you look at the video recording I made for question number 5 in this homework number 2, you probably can better understand what I'm trying to do here. So what I'm trying to do here is, even though the first payment starts from year 6, so relative to the true current year, year 6 obviously is not year 1, it's not the end of the year, right? But we can move our baseline year. We can move the baseline year to be year 5. Hence, relative to year 5, year 6 becomes the end of the year. So that means we can try to get the present value in terms of year 1, year 5 first. And when we stand at year 5 and look forward, and this is a annuity, right? This is a classical ordinary annuity, because the first payment now starts from the end of the year. So once we have this present value in terms of year 5, remember we still haven't figured out the true present value yet, because that's what the question is asking us, the present value in terms of year 0. But once we have this number, suppose we figure that out. I think that's easy to do, because we can just use this formula to figure that out. And every input is known. So once we have that, how can we solve out the true present value? I guess we can just discount, right? We can just discount this present value in terms of year 5 back to the true present. By how many periods? 5. We have 5 years in between the true present, year 0, and year 5. So what about the other cash flows after year 5? We have year 6, year 7, 8, and up until year 20. Every year we also have those constant cash flows. Why can't we just discount those cash flows? Remember, now that tests our understanding for the meaning of present value. So by this present value in terms of year 5, this single number actually summarizes all these future cash flows. Because as we said, the meaning of present value is that it's equivalent in worth to these cash flows. So that means if you give me two options, option 1, you give me this present value in terms of year 5. That's option 1. And option 2, you give me $4,300 every year starting from year 6 and continue that until year 20. Basically, I'm indifferent between these two options. So that's what present value means. So extending that argument, suppose I have this present value in terms of year 5. That single number basically summarizes all these future constant payments, because they have the same value, same worth to me. So once I have this number, I can forget about all these future cash flows. I can just deal with this single number. So the rest of the job is simply to figure out what is the true present value of this present value in terms of year 5. Remember when we said present value in terms of year 5, we have moved our baseline to year 5 to say that. But when we move back to the true present year 0, relative to year 0, this becomes the future. So then we can use the present value of a single future cash flow to figure out the true present value. You see, we can actually follow 2 steps to solve this question. Step 1, okay, step 1. Calculate present value in terms of year 5. Okay, as based on discussion, that step is based on we move our baseline to year 5. Hence, why do we do that? Because we want to use the formula for the present value of ordinary annuity, and that formula only applies when the first payment starts from the end of the year or starts from next year. You can see, starts from next year. So that's why we have to move our baseline to year 5, because the first payment starts from year 6. So that's the first step. Figure out the present value in terms of year 5. I think this step is very straightforward based on our discussion. The payment is 4,300, and the interest rate, what is the interest rate? Go back to the setup. That's 10%. Again, that's the discount rate, 10%. And what about T? Again, I think I mentioned this in class, but I want to stress this again because this is very important. T here stands for the number of payments. So in the formula, the T is the same as the year number. And that's because the first payment starts from year 1. But in this case, it doesn't start from year 1. So T refers to the number of payments. So how many payments do we have? From year 6, right? The first payment starts from year 6 and continue that until year 20. So how many payments are in between year 6 and year 20? You may be tempted to think that, okay, it's the difference between 6 and 20, so that's 14. But that number is wrong because you didn't count 6. By taking the difference between 6 and 20, you are actually counting the number of years between year 6 and year 20. So that's what this 14 means. You have 14 years to go between year 6 and year 20. But what we need here is the number of payments. So that also requires the starting year, which is year 6. So you need to add 14 by 1 to get the number of payments, which is 15 here. So T here should be 15 rather than 14. And this is very, very important. Let me circle this with a blue curve, blue circle, just to stress it. T equals 15. Okay, so now we can plug in these numbers into the formula to get the present value in terms of year 5. So that's 4,300 times, so let me get some more space. 1 minus 1 plus 10%, the interest rate raised to the power of negative 50. And then everything divided by the interest rate, 10%. So then let's use the calculator to figure out this answer. So we have 4,000 Okay, I need to slow down a little bit. Sometimes this is very sensitive. Times. Okay, I guess I need probably I need a two parentheses sign. Yeah, I guess I need two parentheses sign. One minus, then another parenthesis. One plus the interest rate, 10%, right? So that's gonna be 0.1. And then right parentheses. And then the power function. Power. Now I need another parenthesis because this is a negative power. So I need to put that into parentheses, which is based on our discussion is 15. Negative 15. So right parentheses. And everything parentheses back. So then divide that by divide everything by 0.1. So I guess I don't need this first parentheses. Just one should be sufficient. Yeah. Okay, so that's for the present value in terms of year 5. 32,706.14. Okay, 706.14. So far so good. That's our first step. We figure out the present value in terms of year 5. But again, what we need is not this number. What we need is the true present value. But I hope that by now we can understand the meaning of present value means that once we have this single number, we can forget about all those future constant payments, right? We can just deal with this single number. So then the second step, step 2, is to calculate the true present. So relative to the true present value, true present moment, year 5 now becomes the future. So we are basically dealing with this future. So now why don't I just erase all these so you can better understand what I mean. By having this single number, present value in terms of year 5, as I said, I can forget about all those future cash flows because basically this single number, present value in terms of year 5, summarizes all these future cash flows. They have the same worth, same value to me. So I mean different. That's why I can forget about them. It summarizes all of these cash flows. So now relative to the true present, year 5 becomes the future. So now we need, because this is a single cash flow, so we need the formula for the present value of a single cash flow. So the present value equals, again, present value in terms of year 5 here is actually the future value in this case, because that's relative to the true present. And then times 1 plus interest rate r raised to the power of negative 5. Right, there are 5 years between. So now further plug in the numbers. 32,706.14 times 1 plus 10% raised to the power of negative 5. So now let's put these numbers into the calculator. You see, I can further just input these times because I got this present value in terms of year 5. So times, oh gosh, too many times. Multiply by left parentheses 1 plus the interest rate 10%, and right parentheses, now power. I need a negative number, so I need another parentheses, and negative 5 right parentheses. Alright, enter. So that's my final answer, 20,307.94. So put that back to my note. 20,307.94. Okay, so let's put this number back to see whether we got the right answer. Okay. Okay, so this kind of what's the number again? 20,307.94. Okay, 20,309.307. Sorry. 307.94. Okay, check my work. Okay. Yes, we got it right. So again, I want to use this example. I hope that I have helped you to better understand how to solve questions on ordinary annuity. But the first payment doesn't start from year 1, and in this case, it starts from year 6. So again, you need to move your baseline to the date where the first payment starts from next year, and then you can use the formula. And after you do that, you just calculate the present value of that present value in terms of that specific date. So by taking these 2 steps, we can solve this type of questions. Alright, so that's it for the discussion.